Hello, Cosmos Explorers. Welcome back to Cosmosphere. In the silence between the stars, a wanderer emerges. Not from our solar system, not from any place we know. A comet, older than planets. Older than our Sunday 3I/Atlas, an ancient messenger from the edge of interstellar space, has entered our neighborhood. What secrets does it carry? And where, in this unfathomable universe, did it begin its journey? Before 2017, no confirmed interstellar object had been observed passing through our solar system. But then came Oumuamua, an elongated, tumbling object with no comet-like tail. 2 years later, 2I/Borisov appeared, exhibiting a more familiar cometary nature. Now a third object joins this rare group, 3I/Atlas, and it might be the oldest of them all. In February 2024, the ATLAS Asteroid Terrestrial Impact Last Alert System survey detected an object with a hyperbolic orbit, one not bound to the gravity of the Sun. The object was already heading out of the solar system, moving fast enough to escape permanently. It was given the designation 3I/Atlas, marking it as the third interstellar object ever confirmed. To understand the nature of 3I/Atlas, scientists turned to orbital mechanics. Its trajectory indicated that it came from far beyond the outermost reaches of our solar system. Unlike objects originating from the Oort cloud, which are loosely bound by the Sun's gravity, Atlas was entering on a steep, hyperbolic path, one consistent with interstellar origin. It entered from above the plane of the solar system and did not match the orbital patterns of long-period comets. Its velocity, too, was higher than average, another telltale sign of interstellar origin. The evidence was clear. This was a true visitor from the stars. The physical and chemical characteristics of 3I/Atlas added a deeper layer to its story. Spectroscopic observations of the object's coma, its thin envelope of gas and dust, revealed something unusual. It appeared to be significantly depleted in volatile compounds. Volatile elements such as cyanogen, carbon monoxide, and water ice are typically abundant in fresh comets from the outer solar system. But 3I/Atlas displayed signs of long-term exposure to cosmic radiation. This implies that the comet may have spent millions, or even billions, of years drifting through the interstellar void. Its darkened surface, likely eroded by constant exposure to galactic cosmic rays, points to an unimaginably ancient journey. The chemical fingerprint it carries suggests that this object has not been part of a solar system for an incredibly long time. How old is 3I/Atlas? That question leads us to the dynamics of the Milky Way galaxy itself. Ejection events are common in the early life of planetary systems. As giant planets form and migrate, they can gravitationally fling smaller objects out into interstellar space. Over time, some of these objects drift between the stars, potentially for billions of years. As they travel, they collect radiation damage, lose their volatile materials, and darken. If Atlas was ejected during the chaotic youth of another planetary system, perhaps one long gone, it would serve as a relic of that lost world. Its passage through our solar system may be brief, but it offers a rare opportunity. A look at primordial material formed around a distant star, possibly even older than our own. Comparisons to Oumuamua are inevitable. While Oumuamua lacked a visible coma and had a strange, elongated shape, 3I/Atlas appears more like a traditional comet. This suggests that interstellar visitors can vary greatly in structure and activity, depending on their age, composition, and exposure history. Where Oumuamua surprised scientists with its peculiar acceleration and silence, Atlas has been more straightforward in behavior. However, its extreme age makes it uniquely important. It tells us that the interstellar medium may be filled with countless such relics, each carrying different tales of origin and survival. After its closest approach to the Sun, 3I/Atlas began to fade. It showed limited activity and never reached the brightness levels of typical comets. In many ways, it passed through the solar system like a ghost, silent and ancient. Unlike comets that loop back into our view after decades or centuries, Atlas is on a one-way trip. Its hyperbolic path ensures it will not return. It was here only briefly, and now it continues into the unknown. Its trajectory takes it out of the solar system forever. Yet, in that fleeting moment, it left behind data and mystery, a snapshot of the deep past. Atlas reminds us that space is not empty. It is filled with the cast-offs of ancient systems, remnants of planetary formation and destruction. Interstellar comets are more than cosmic debris. They are time capsules. The presence of 3 interstellar objects in just a few years suggests that the galaxy may be teeming with such visitors. Most are too faint to detect, passing silently through the darkness. But as detection methods improve, we may begin to see more of them and learn more about the galaxy's history. These objects may also be carriers of organic compounds. If they collide with young planets, they could even help seed life. In that sense, comets like 3I/Atlas are not only relics, they are messengers, and perhaps even catalysts of creation. 3I/Atlas is gone now, a traveler whose journey began long before Earth existed. We may never know the full story of its origin, or the star it once circled. But for a brief moment, it became part of our cosmic story. And as we continue to search the skies, we'll wait for the next whisper from the void. Another visitor. Another tale from the stars.